Okay, hi everyone. So welcome back to our class. And we will talk about the final project this Thursday because I still want to I want to final check about the final project. So we won't talk about it today, but we will definitely talk about the final project this Thursday. And I will probably announce the description of the final project before this Thursday. And basically, I just wrote everything on the document. So please make sure you read the description of the final project before this Thursday. And I will have a quick explanation about the final project during the class. And you will have the time to ask any question about the final project during this Thursday. So today, let's start another new topic. So last week we talked about the loops, right? We introduced 3 interactive statements: for loop, do loop, and while loops. We also introduced the jump statements. We can use break, continue, and go to change the execution flow of our program. So basically, we already introduced the selection statement and the loop statement, iterative statement. So that means that you have most of the basic tools for you to write more complicated exercise or complicated program. And today, what I want to introduce is I would say detailed but important things about C. And it's not only about C, I think this concept is the same for most of the modern programming language. And the topic is basic type. So we already saw some basic type in the previous course, right? We know we have the integer variable, we have the integer value, we also have the floating point value and the float variable. But those 2 things are just 2 of the basic type we can use in C, and we actually have more basic types. So in this week, we will introduce all the things you need to know about basic types. Today we will introduce more things about integer types and float types. And we will introduce a new type here that is character type. And we will call it char. So we will talk about that in today's course. So just like I said, C has several basic types. So the meaning of basic is that those types are built in C. So that means that we don't need to create this type by ourselves. We can directly use this built-in type in C. And we have the integer types. And the integer type, we can have a long integer, short integer, and unsigned integer. And we will talk about the meaning of the long, short, and unsigned in the later slide. But you can see that just for one integer, we have more types of integer. We also have the floating type. So in the previous course, we basically introduced the float type, but actually we can also have the other type called double. So double is also a floating type. We can even have a long double, and we will also introduce this in today's course. And finally, we have another type is character type. And to declare character type, we use these abbreviations, CHAR. So instead of saying caricature every time, because it's a long word, right? So instead of saying caricatures, for the most of the time we will say just a char type. So the way to pronounce it is char. So when I say char variable or char type, that means that this is a caricature variable and caricature type. And also in C have another built-in type that is bool here. So what is interesting is that actually C announced its new version in 2023, and there are some changes between in C 2023, and the most important change, not the most important, that the change relates to today's topic is that they C changed the building board type from this form into this. So you no longer need to write down the underscore and the bool, B-O-L, like this. You can directly write down B-O-O-L, all in the lowercase, to use the bool type in C. So bool is also one of the building type in C. Okay, so let's check out the tree we have here. So this tree just show you of the data types we have in C. And the primary data type, so data type we use DT. So the primary DT, the primary data type, are the basic type we're going to introduce today. And we also introduce the user-defined data type and the other data type in this course. And I will say mostly we'll introduce in this course, but I will say we'll introduce the structure and enumeration in the course in the next semester. But today, we just need to focus on this part, the primary, the basic data type. And of course, the first data type we're going to focus is the data type integer. So that is the data type I guess most of you are familiar with, right? The integer. So you can see integer have all these subtype for this integer data type. So first, let's review something about integer and floating point. So in C, it supports two different kinds of numeric type. The first one is integer type, so something like this. So integer type basically represents the number without fractional part. That is the number without the decimal points and the number after decimal point. So for the integer type, there's no fractional part. And then the other kind of new number we can use in C is floating point type, or we can just call it floating type. So for the floating type, you can see if we represent the number in the floating type, it has the fractional part. That is, it will have the decimal point, the point here after 9, and the number 1, 2, 3 after the decimal point. So this kind of number is a floating type, is a floating point number. So for the integer type, it actually we can further divide the integer type into two categories. The first category is called signed, and the other is called unsigned. So what is the meaning of signed and unsigned? So the word signed, the meaning of it is kind of like, in Chinese we'll call it 标记, something like that. So sign means that there is some sign for the integer number. Unsigned means there's no sign for the number. So the meaning is pretty straightforward, I would say. So for the signed number, it's the numbers that we can divide it into like positive number and negative number. So for the signed number, we have positive and negative number. For the unsigned number, that means that we cannot add the sign to the number. So unsigned number means that those integer numbers have no negative value. So we will call them unsigned number. So the major difference between the signed and unsigned is that we can have negative value for the signed number, and for unsigned number, we cannot have negative value for unsigned number. Because to represent a negative value, we need to put the minus sign in front of the number, right? So for the unsigned number, we don't have the minus sign, so there's no negative value. So how can C or our computer understand the sign of integer. So to talk about that, first we need to introduce the concept of bit and byte. So for any signed numbers, our computer will use the leftmost bit of it to represent the sign. So if the number is positive or 0, the leftmost bit of this signed number is 0. So, and if the number is negative number, then the leftmost bit of the negative number will be 1. So the leftmost bit, so leftmost means 最左边. So leftmost bit, the leftmost bit of the signed integer, we will call it the signed bit. So I believe for some of you, you might have the question is what is the bit if you don't have the concept about bit and byte. So bit is the smallest unit of storage in our computer, in your computer. So, and you should know, in the world of computers, the smallest unit is bit, right? And we will, if we have 8 bits like this, we will call it 1 byte. So maybe some of you will feel more familiar with the word byte, because byte, this B-Y-T-E, is actually the meaning of the B, KB, MB, GB, we have TB. So in our computer, you may see something like this. We can see the size of different file, right? So the size, we have the file with 71 KB. That is, we have 71,000 bytes for this file. So bytes is represent for the B we have for the file size, and you need to remember 1 byte in our computer equals to 8 bits. So we can use these 8 bits to represent any data in our computer. So actually for any integer or floating point numbers, we can use different bits to represent it in our computer. So that is why we always say that the word of the computer is 1, 0, and 1, 0, right? So because we can use 1 and 0 to represent any information we store in our computer. So to know the meaning of the bits, we need to know the other thing that is called binary computations. So actually, all the meaning of those bits, they are represented in the binary format. So what is the meaning of binary format here? So the number we use for our daily life is a decimal number, right? Decimal number means 十进位. So when we count to 9, we need to write down, when we count to 9, the next number of 9 is 10. And then this kind of thing are called decimal computation. However, in the world of the computer, they don't use decimal computation, they use binary computation. So binary computations is called 二进位. So how to calculate, how to understand the value in the binary format. So here is the picture to tell you how to calculate binary number. So we can convert the binary number to the decimal number. So let's assume that we have this binary number here, that is 0, 1, 1, 1, 1, 0, 1, 1. And to so what we need to know is that every bit we have here, so each blue box is 1 bit. And these bits have the sequence is from right to the left. And the leftmost bit is the first digit of this binary number. So to calculate this binary number into decimal number, we need to calculate the first digit as this. So the first digits represent 2, 0 here, And because the value of these digits is 1, so we calculate 1 multiply 2, 0 here, right? And the second digit is 1, so for the second digit, we need to multiply 1 to 2, 1 here. So you can think about this is really similar with the decimal number, because if we want to calculate the decimal number, we actually do the same things. So what we did, for example, if I want to calculate the value of 12 in decimal format, I can write down 12, right? And for this 2 actually represent 2 multiply 10 to the power of 0 here, and 1 represent 1 multiply 10 to the power of 1. And to add to number is 12, okay? Because 10 to the any number to the power of 0 equal to 1, okay? So we can apply the same concept in the binary computation here. The only difference is that instead of multiply 10 to the power of n, we multiply the value we have in each digit to the 2 to the power of n, based on which digit this number is at. And then after we calculate the value of all the digits here, we just sum them up, and then we can get the decimal value of this binary number. Okay, so that is, I would say this is a basic computation, and if you will also use it in other course. So please make sure you understand how to do the binary computation. And we will introduce more other kind of computation in this course. And I would say those computations are very important, and I would say they are fundamental knowledge for the more advanced course. Okay, so let's go back to the signed and unsigned integer. So let's say that we have the, so in the most of the computer in C or in the traditional computer, the old-fashioned computer, most of the time, we use the 16-bit to represent integer in C. So the largest 16-bit integers have this binary representation. So because this is a signed integer, so we need to reserve the leftmost bit to be the signed bit, because this signed bit can let us know whether this value is positive or negative. And since we use 16-bit to represent an integer, we have a 16 number here, and this one is used for the signed bit. So the remaining 15 bits are used to represent the number of this signed integer. And the biggest number for the 16 signed bit integer can be represented like this. So all the bits are 1 except the signed bit. And if you take some time to convert this binary value back to the decimal value, you will get the value here. So this is the largest number for a 16-bit signed integer. Okay, so this is signed bits. Okay. And I also write down a quicker way to calculate this number here. So this is the conventional, this is the traditional way to calculate the decimal number of this binary number here, right? So we just add all these numbers together, because all the number is 1, so we don't need to write down 1 multiply 2 to the power of 0, 1, 2, 3, till 14 all the time, so we just write down something like this. However, a more quicker way to calculate this is actually rewrite this calculation into this. So actually these two values are the same. So to calculate, to know the sum of this, we just need to advance 1 digit So we just calculate the number of 2 to the power of 15 and then minus 1. And this number will equal to the result of this calculation. And if we use 32-bit to represent a signed integer, then the largest number we can have is like this. So the more bits we use to represent the integer, the range of the integer will be bigger. So you can see that we have 31 digits here, and then we reserve the leftmost digit for the signed bit in this case. So this is how we can use the binary representation to write down the largest numbers for the 32-bit signed integer. So that means that if you have this integer, it cannot store the value larger than the value here, because this is the largest value that this 32-bit signed integer can store. Okay, but maybe some of you will already think about, but now my computer is like 64 bits, right? So that is true. So 64-bit CPU or computer are more common in nowadays. However, it is waste of the space if you use 64-bit to represent any integer in your computer, right? Because so for most of the time, we won't use this large number. So the largest value of 64-bit CPU is the same as the 32-bit integer. So for the 64-bit computer, this computer will usually still use 32-bit to represent the integer value. However, if we know that I'm gonna store a really large number, we can declare the integer variable as a long integer. So we will introduce this type in a later slide, but this long integer variable allowed us to use 64 bits, all the bits, to store the large integer number. So this slide here introduces the largest value for the signed integer, and how about the unsigned integer? So because for the unsigned integer, we don't need to have the signed bit, right? Because there's no sign for the unsigned integer. So that means that the unsigned integer can use all the bits to represent number. So that is why the largest 16-bit unsigned integer is this, the number here. And you can see this number is larger than the number we have here, because for the signed integer, it cannot use the leftmost bit to represent number. And I will say there's no need to remember the number here, because this is a very huge number. All you need to do is to understand why the unsigned integer have the larger maximum value than the signed integer, and how this value can be calculated. So that is the two things you need to remember, and there's no need to remember the exact number here. So by the default, if we just write down the int j, then the integer variable in C will by default to be signed integer. So that means that the leftmost bit will be treated as signed bit. And if we want to declare an unsigned integer, we need to write down the unsigned when we declare the integer variable. So instead of writing int I, we need to write down unsigned int I. So I will be unsigned integer variable. And maybe some of you might think about, okay, so what is the purpose of using unsigned integer? So actually, unsigned integer is useful for system programming and low-level machine-dependent applications. And since we haven't introduced this low-level programming right now, so I won't go too much into that topic here, but just remember the unsigned integer have its special use. Because unsigned integer, we don't need to remember that the leftmost bit is for the signed bit. We can use the entire bit to do low level or the bitwise computations. So we will talk about that, and you will probably learn about this in other course, like the course about the digital design or the other system programming course. Okay. So after finish how to declare the unsigned integer, let's talk about how to declare the long integer. So the long integer means that this integer can have more bits than the ordinary integer. For example, if I want to use 32 bits to store a super large integer value, then I will like to declare the variable to be long int, because if we declare the integer variable as a long integer, that means that this long integer will use 32 bits to store the integer value. So if you know that in your application, in your programs, you will store the value that is larger than the value here, then you should declare the variable as a long int. And if you want to store even larger integer value in your variable, then you need to declare, you can declare long int. So this long int variable, this variable uses 64 bits to represent the integer value. So that is why it can store even larger integer number. And we can also declare an integer to be short integer. So long integer is for the situation that you want to use more bits to represent the integer value. So for the short integer, that means that I want to use fewer bits to represent the integer value I have. So in what situation we want to use fewer bits? So in the situation that you want to save your device memory, and you know that the maximum number in your program is gonna be very small. So in that case, you can declare an integer variable to be short integer variable so that you can save more space. So to declare short integer variable is very straightforward here. You just write down short integer in k, and then you have the integer variable k, and it is the short integer. So actually we can combine the long and short with the signed and unsigned with this int to declare different integer types. For example, we can have a unsigned int, we can have unsigned long, we can have unsigned long, we can also have a short int or unsigned short int. So you can see we can have a different kind, we can have various types of the integer variable by using those keywords all together. And you can see that, so although I write down the order of the unsigned, long, and int like this, however, the order of this specifier, so the specifier means the long, the short, int, and unsigned. So the order of those keywords, those specifiers, doesn't matter actually. So we can write down for example, we can rewrite the unsigned int, unsigned long int to be long unsigned int. We can also rewrite the unsigned short int to become the short unsigned int. And moreover, we can also drop the int word when we declare the integer variable if we have a long and short in the declarations. So the long int can be abbreviated into just long. So we can directly write down long int, long I. So this long I is equal to long int I. And that is the same for the short k. So short itself is the abbreviation of the short int. And that is the same for this case here. This case we have an unsigned loan int, and we can actually remove the int, and we can just write down unsigned loan. That this line is the same with these lines here. And actually the range of the value represented by different integer type is different from one machine to another machine. So that is why I say this is pointless to remember the exact number of the maximum value for different integer types, because this value will change in different computer. However, there are some general rules for them. For example, C standard require that the short integer and the long integer must cover a certain minimum range of the value. So it is hard to know the maximum range, but we can know the minimum range of different integer types. But again, I will say it is, we don't need to remember the minimum range by ourselves, because you can always go online to check it out. And also in the library called limit, in this limit library, we will also define the information of the minimum range of different type of integer. So if you want to know that, just check out the contents in this header file. Okay, so this is just what I said earlier. You don't need to remember the exact range, just need to know where this range comes from and why this is the range for the 16-bit integer. So the next topic I'm gonna introduce is the topic related to the binary computations. So except the binary computation, we actually need to learn other two more computation, that is octal computations and hexadecimal computations. So we can actually write down those numbers in C. So we'll call this integer constant. So all these things are integer constant. They just represent in a different format. So you all know the decimal number, right? So decimal number is the number base 10, 十进位. And the octal number is the number base 8. So in Chinese we call it 八进位. And we have hexadecimal numbers. So hexadecimal numbers is the number based on 16. So we will call this 16进位. So this is the example of how we can write down the integer constant in different formats in C. So in this case, I can declare an integer variable k, and I can assign different number to k. So I can assign 15 in k in decimal format, and I can also write down the number like this. So the number that is actually an octal number. And if we convert this octal number back to decimal number, this number is 15. And also, this hexadecimal number is 15 in the hexadecimal format. So in the following slide, I'm gonna tell you how to convert between all those formats, and I will tell you why we need to learn how to calculate octal, hexadecimal, and binary number. So one thing is that I know if it is the first time you encounter all these numbers, it might be hard to remember the meaning of decimal, octal, hexadecimal, and binary, right? I think binary is easier to remember, right? Because bi means 2, so binary means 2, so that is why we have 0 and 1. And then I want to introduce the trick I used for myself to remember the meaning of decimal, octal, and hexadecimal. So to remember decimal means 十进位. You just need to understand the what is the meaning of DEC stand for. So I believe most of you know this word, right? Decade, right? Decade means 10年, 10 years. So decade also have DEC. So you know that the meaning of DEC is 10. So decimal means number base 10, based on 10. And I would say the octal number is easier to remember because I believe all of you know this word, right? Octopus. So I put a cute octopus here. So how many legs an octopus have? Let's assume that this octopus is an octopus without any injury, okay? So the normal octopus will have 8 arms. So that is why it is called octopus. So the meaning of OCT, oct, is actually have the meaning 8. So that is why the octal number means 八进位, number based on 8. And the final word is a more complicated, it's hexadecimal. So I don't have a better way to help you to remember this, but you can divide the hexadecimal into 2 parts. So hex is here, and decimal is here. So the meaning of hex is 6, and the meaning of decimal, DEC is 10. So 6 plus 10 is 16. So hexadecimal is the number based on 16, 16进位. So I hope this can help you to remember the meaning of these 3 special terms. So now let's start to how to calculate or how to understand the octal and hexadecimal number. So octal number means that this is based on 8, right? So the number we have in the octal number can only range from the digits 0 to 7. Because if the number is 8, then we need to 进位, right? So for the octal number, we can only see the digits from 0 to 7. And each position in the octal number represents a power of 8. For example, if we have the octal number 237, how to convert it back to decimal number? So to do that, we just write down that just like I explained here and what I explained for the binary computation. You just need to write down the calculation like this. So you multiply 7 with the a to the power of 0 here, because 7 is at the first position here. And for 3, it's at the second position, so it multiply a to the power of 1. And then you just continue to convert this number into this calculation, this formula. And then you add all the numbers together, then you can get the decimal number for this octal number. So actually, we use the same strategy to convert the hexadecimal number into decimal number. But for the hexadecimal number, it's more complicated because it needs to have a 15 number in the hexadecimal number. So this is the table to show you the value of each hexadecimal digit in decimal number. So you can see until 9, the hexadecimal number you use the same digits with the decimal number. However, for the value larger than 9, hexadecimal number use the alphabet A to F to represent the number from 10 to 15. So this is the digits for the hexadecimal number. And to calculate the hexadecimal numbers back to the decimal number, we just apply the same strategy here. So we need to identify the value of F, what value the F alphabet represents. So F represents 15. So that is why we multiply 15 with 16 to the power of 0 here, because it is in the first position. And we apply the same calculation to the second and the third position. and we add all those values together, and the final result is the decimal number of this hexadecimal value. So this is how we can convert back and forth from decimal and hexadecimal. Okay, so now I want to talk about why we need to learn those octal and hexadecimal number, because in daily life we don't really calculate everything in octal and hexadecimal, right? And in the programs we wrote right now, it seems that we can directly use the decimal number to do all the calculations. So why we need to learn those two awkward or new representations? So the reason is that we need to understand the computer. For computer don't calculate in the decimal value. Computer is a binary system. So for computer, each number is binary, need to be in binary representations. So it is easier to computer to convert back and forth between binary or the value that is closer to binary representations. So if we represent a number for octal and hexadecimal, actually this is easier for computer to understand. For example, actually if we have the octal number like this, 2, 3, 7, we can easily convert this octal number to the binary number like this. So I use different color to label different value here. So you can see that for the octal number, because 8 is 2 to the power of 3, right? So that means that for each octal digit, it represents 3 digits in the binary calculation. So we can actually expand 7 in the octal number into 3 digits in the binary number here. And it is easier to calculate the number 7 in the binary format, right? So use the binary format to calculate 7, we just write down 111. And this is the same for 3. So the middle digit in the octal number 3 can expand into these 3 digits in the in the binary format. And the binary number of 3 is 0, 1, 1. Okay, so I just assume that you guys already know how to calculate the binary numbers. So 0, 1, 1 is 1 plus 2, so that is 3. And we can expand the final digit in the octal number into this 3 digits in the binary number, that is 0, 1, 0. So you can see to convert between octal and binary is pretty easy, right? And that is the same for the hexadecimal number here. So I just use the same coloring here to represent the mapping between the digits in the hexadecimal number and the binary number here. Because 16 is equals to 2 to the power of 4. So every hexadecimal digit represents 4 binary digits. So that is why it's easy to convert between hexadecimal and the binary value. And also you might feel the hexadecimal number is pretty familiar if you ever built website or write the CSS by yourself. So actually in the front end, we actually use the hexadecimal value to represent different colors. So you can see the number of color you saw on the website are actually in the hexadecimal numbers. And also the address and the location of the computer memory is also in the hexadecimal format. So hexadecimal number is actually pretty useful in the world of the computer science. So it will be important to understand what is a hexadecimal number and how to calculate them. So again, before the break, I want to quickly wrap up all the different values we introduced in the previous slide. First, we introduced decimal constant. So decimal constant is the value, it contains the digit between 0 and 9. And if we need to write down the decimal constant in our C code, then we need to write down the number directly. And the most important is please don't begin the number with a 0 in C. Because if you add a 0 in front of the integer constant, then your computer will think this is an octal constant. Because in C, if you want to write down integer constant in the octal format, you need to add a 0 at the beginning. So this is how we can write down octal integer constant in C. Finally, how can we write down the hexadecimal constant number in C? So to write down hexadecimal number in C, we just write down the correct digit for hexadecimal number first, and we need to begin this number with a 0x. So don't ask me why it's 0x. This is a design of C. So if you saw this kind of number in C, then you know what the number after the 0x is in the hexadecimal format. And you can see the later in the hexadecimal constants doesn't matter. It can be uppercase or lowercase. So you can write FF in the uppercase, but you can also write FF in the lowercase. And the X in the 0x can be lowercase x or the uppercase x. All those things are the correct hexadecimal integer constant in C. Okay, that is all for the first half of the course. And please come back here after 4 minutes.